Hello guys, in today's video I'll be talking about this 3D printer. You know, I had a 3D printer for a while. This is a Einstard S 3D printer, desktop printer. And I had a bit of a problem with it because I was not able to get this printer printing stuff because there was no software for it. You know, you had a micro SD card with this 3D printer and the software was on this micro SD card. So when I lost the micro SD card, I basically am not able to print anything on this 3D printer. So what I thought about is that, you know, there is this thingy called RAMPS 1.4, this thingy. So I thought I will buy this. I will replace the electronics inside. This is the electronics that were in the thing. As you can see, we have some voltage converters, some USB thingies, a blob of hot glue here. I don't know why it is there. Some microcontroller, which is even, I think, 80 mega or some Atmel. Some stepper motor drivers with some filtering, some MOSFETs for switching on and off other things. And it was powered by 24 volts. And there was a small little LCD panel for it, which I have somewhere. And what I thought, you know, I will replace this electronics and it will be okay. It will be fine, you know. And then everyone will be happy. I'll be able to print stuff. So I thought like that. I bought this thingy. You can see this thingy here, right in there. Here I have, you know, Pololu drivers, you know, stepper motor drivers inside these sockets. And we have X, Y, Z and extruder connected in there. And here we have connected the heater. The heater is 24 volts, so I needed to convert some things. So here I have a MOSFET connected up to 24 volts, so that here we have the 12 volt into this board, and then here we have a MOSFET that switches on and off the nozzle, which we have right in here. You can see the nozzle. Here we got a nozzle, and the nozzle is 24 volt, as well as the fan, which is here. This fan, you can see it. This fan is 24 volt too, so I needed to switch stuff on and off with 24 volt. So bam, I'm using this transistor. And you know, there was a lot of problems to get this thing running. And I realized, you know, not always the most, like the software that is the most difficult one, or maybe the most complicated software is the best one. Not this time. So let me show you a small simple schematic of how to connect things. Here we have the schematic on the RepRap website. Here we have the schematic. As you can see, stepper motors. I think anyone who is into electronics for a while should be able to connect those things up. And I have already printed some things, didn't record them, but this is basically how my first tries look like. The first tests. As you can see, X, Y, and Z are working. This should be a cube, and this is a rectangular shape, so it should be a cube, so it means that the Z axis is a bit stretched in this 3D printer, which I'm not particularly happy about. But, you know, what can I do about that? It's a bit stretched, and as you can see, it works. When it comes to the filament, I made this nice wooden thingy, as you can see, with some angle brackets, a bit of wood, and other angle brackets, you know, L-shaped brackets. And it basically, the filament sits here, and the 3D printer needs it. It can pull on the thing like that. Oopsie, there's some problems with it, but it can basically pull the stuff, and it's pretty stable. I built it like that because with this 3D printer, it's pretty old. I don't have any type of stand for the filament, so I needed to build something like that. I had a lot of problems with this 3D printer, but mainly the biggest problem was to get the Z-axis, which is the horizontal axis, working. We have X and Y axes on the bed, and we have Z axis, which works, you know, up and down. And what I needed to do, as you can see, a bit of a contraption with a rod, here a bit of thick wire, and a pad here connected with another wire, because this 3D printer originally had the switch here on the bottom. Here was, the contactor switch, which I didn't like it because, the home position for the 3D printer is when it starts printing, the beginning of the printing starts from home position. And the home position for this 3D printer was here. So it was a bit of problematic. But what I thought I will do is I will basically make a contact like that with a piece of rod and a pad. And I did it this way. So now when it goes to a home position, it's pretty close to a nozzle, close enough so that it can start printing straight away. So, let's talk a bit more about electronics. So we have the USB cable coming from my laptop so I can upload stuff onto this microSD card here. So that it can print off of the microSD card, not from the PC. Then here we have this MOSFET transistor. We have the bundle of cables under the MOSFET. Here we have two ribbon cables connecting the display on the front. And here we have the first power supply, which is for the motors. We have 230 volts fed in through the switch to this power supply and this 24 volt big power supply that can deliver up to 5 amps. And here we have 12 volt 5 amp power supply, but this one is not so trusted one. This one I know can deliver 5 or even more amps, up to like 7 and something, but this one can deliver only 5 amps and I don't trust it much. So this one is powering only motors and it's enough. And what's worth noticing is that stepper motors don't need very high current to hold torque very nicely. They have high torque, but in order for them to hold in position, you need to deliver still power to them. And you don't need to feed this power like the highest possible current into them. The rated current is like 1 something amps in those motors. So this won't be even able to deliver that much current. So what those Pololu drivers give you is those nice small potentiometers that you can see here, right in here, this small potentiometer. And it lets you to basically decrease the amount of current that is delivered to the motor, which is fairly nice, which is fairly good because it lets you to decrease the current that goes into those motors because they don't need so much. We are not building a CNC machine here, it's only a 3D printer. We just want them to hold their torque and that's it, so that our bed won't fall down. Right now it's obviously supported by those nice scissors. But we don't want our bed to basically fall down and nothing else. We don't need a very high, torque or very high force applied onto the bed or anything or to the nozzle or whatever, because we are not CNCing with this, So basically, if you like this idea, if you want to see a bit more in-depth explanation and problems, it would be nice to basically see you commenting. If you will be asking about the software that I used, it's Pronterface. As you can see, Pronterface, this is the software that I'm using. It's very simple, it's a bit old and it doesn't have a lot of features, but it worked for me and I had no problems with it. I had Repetier Host and the Repetier Host didn't work at all for this project, so it was a bit of a mess when I was doing stuff in Repetier Host. So I don't recommend Repetier Host if you're replacing electronics like I am, you're hacking out with a printer. I don't recommend Repetier. There's too much parameters that you need to define when it depends to your printer. This is what I recommend. If you would like to see or hear a bit more in-depth explanation what exact problems I had with this 3D printer and what type of mistakes did I made when configuring Marlin, because it's running on Marlin, and the host, type of computer software is Pronterface. So if you want to see a bit more in-depth explanation, I would really like to see likes under this video and comments. So see you guys next time.